Hey everyone, are you ready to finally master lenses? Because by the end of this A1 Institute Explainer, I promise you'll be able to tackle any lens problem that comes your way in your Class 10 exams. So let's jump right in. I totally get it. Ray diagrams, all those formulas, they can look pretty intimidating at first glance, right? With all the different lines, the plus and minus signs, it can feel like a lot. But trust me, it's all built on just a few super simple logical rules. If you stick with me, we're going to turn all that confusion into total clarity, one easy step at a time. And hey, a quick shout out to A1 Institute for making this whole explainer possible. If you want more awesome content like this to help you ace your exams, make sure you hit that like button, share this with your friends, and subscribe to the channel. And if you're looking for full courses, notes, and expert guidance, all the details for that are waiting for you in the description below. Okay, let's get back to it. So here's our game plan. First, we're going to nail down the 3 unbreakable golden rules for drawing rays. Then, we'll put those rules to work to understand both convex and concave lenses. After that, we'll dive into the math with the lens formula. And to wrap it all up, we'll solve a real exam problem together. You ready? Let's do this. Okay, let's start with the absolute foundation of everything. These 3 golden rules. They're your key. Seriously, once you get these down, drawing any ray diagram becomes almost automatic. Think of them as your secret weapon for the exams. What's so amazing about this first rule is just how predictable it is. Any ray of light that comes in parallel to that main center line, the principal axis, it will always get bent by a convex lens and pass right through the principal focus, f2. Just remember this: parallel in, through the focus out. It's really that simple. Now, check this out. Rule number 2 is basically just rule number 1 in reverse. If a ray passes through the principal focus first, before it hits the lens, then the lens bends it so it comes out perfectly parallel to the principal axis. You see that symmetry? It's pretty cool how these patterns work. And here we have the easiest rule of them all. This one's my personal favorite. There's a kind of magic point right in the dead center of the lens. We call it the optical center. Any ray that passes straight through this point, well, it just keeps on going. No bending, no deviation, nothing. This is your go-to ray for drawing diagrams quickly and accurately. All right, so we've got our 3 golden rules. Now let's actually put them into action and see what kind of images a convex or converging lens can create. This is where the fun starts. Let's start with our first case. Picture an object placed pretty far from the lens, somewhere beyond 2f1. Now we just use our rules. Let's draw one ray parallel to the axis. We know that one goes through f2. Then, let's draw our super easy ray right through the optical center. It goes straight. And boom, see where they cross? That's exactly where the top of our image is formed. So, what can we say about this image we just made? Well, for your exams, you always need to describe it using 3 key properties: its position, its size, and its nature. As we saw, its position is between f2 and 2f2. Its size is clearly smaller than the object, so we say it's diminished. And its nature? Because the light rays actually meet up, it's a real image. And as you can see, it's upside down, or inverted. Now, for a really cool case. What happens if we move the object super close to the lens? I mean, right up against it. Look what happens. The rays spread out after passing through the lens, and they're never going to meet on the other side. But our brain is pretty smart. It traces those lines backwards, and it thinks they're coming from a point behind the lens, forming a much bigger image. And that, right there, is exactly how a magnifying glass works. Let's break this one down. Its position, on the same side as the object. Its size, definitely bigger, so we say it's enlarged. And its nature? Well, since the light rays don't actually meet, we call this a virtual image. And as you can see, it's upright or erect. Remember this one. It's the only case where a convex lens gives you a virtual and erect image. Awesome, you've totally handled the convex lens, and honestly, that's the hard part. The good news? The concave lens is way, way easier. It's incredibly predictable, which is fantastic news when you're sitting in an exam. So a concave lens is a diverging lens, which means it spreads light out instead of focusing it. And here is the best part. It doesn't matter where you put the object. The result is always the same. The rays spread out, and when you trace them backwards, they always form a smaller, upright image on the same side. Always. And this table right here proves it. Whether the object is super far away or right up close, the result is the same. The image is always virtual, always erect, and always diminished. Burn this into your memory for your multiple choice questions. A concave lens always forms a virtual, erect, and diminished image. Period. We've totally mastered the art of drawing these diagrams, but what if you need an exact number? What if you need to be precise? Well, that's where the math comes in. So let's shift gears from drawing pictures to using formulas that give us perfect answers every single time. Meet the lens formula. This thing is like a recipe for light. It perfectly connects the object distance, u, the image distance, v, and the focal length, f. If you know any two of those, you can always find the third. But just like any recipe, to get the right result, we have to get our ingredients, and in this case, our signs, exactly right. Okay, I need you to pay really close attention here. The sign convention is where most students make mistakes, but we're going to make it super easy. Just think of the optical center of the lens as the 0 on a number line. Anything to the left is negative, anything to the right is positive. Since we always place the object on the left, u is always going to be negative. And for a convex lens, which focuses light on the right side, its focal length f is positive. Master this, and I promise you've mastered the math. Next up, we have magnification, which we call M. This little letter gives us two huge clues. First, the number itself tells us if the image is bigger or smaller than the object. And second, the sign tells us its nature. If M is negative, the image is real and inverted. If M is positive, it's virtual and erect. It's a really useful shortcut. All right, theory time is over. You've got the rules, you've got the formulas. Now it's time to put it all together and walk through a typical exam problem step by step. Let's see this stuff in action. Okay, let's break this down. Step 1, list what we know and don't forget the signs. Object height is upright, so it's +2. Object distance u is on the left, so it's -15. It's a convex lens, so f is positive, +10. Step 2, plug these values into our lens formula. Step 3, a little bit of algebra, and we solve for v, which comes out to +30 centimeters. The positive sign tells us the image is on the right side. Step 4, now for magnification. M is v over u. That's +30 divided by -15, which gives us -2. The negative sign tells us it's real and inverted. The 2 tells us it's twice as tall. So the final image height is -4 centimeters. And there it is, our complete answer. We're pretty much at the end, but here's a final thought for you to chew on. A camera needs to form a real, inverted, and smaller image on its sensor. So based on everything we've just learned, where would you need to place an object in front of a convex lens to get that exact result? Give it some thought. And just like that, you've done it. You now have all the rules, the formulas, and the confidence to solve any lens problem. You are officially exam ready. Now, if you want to take your preparation to the absolute next level with some in-depth notes and personalized guidance, get in touch with A1 Institute. All the info you need is right there in the description below. Thanks so much for watching this A1 Institute explainer. If this helps you out, do us a huge favor and hit that like button, share it with a friend who might be struggling with this, and of course, subscribe for more exam-ready content. We're rooting for you. Good luck.